Hey guys, hopefully everyone is doing well. Today's target is to solve question number 13.21. The chapter which we are related with is leverage and capital structure managerial finance book by Lawrence Gitman. So today's target is to solve 13.21 and basically this is real light and interesting question where we are trying to make a relationship between EPS, standard deviation, coefficient of variation with debt ratio. So here question has been started, various debt ratios and expected earnings per share EPS standard deviation are given in the following. And what is our requirement? Estimate an optimal debt ratio on the basis of relationship between earning per share and debt ratio. So this is your EPS, earning per share and debt ratio, and they have asked the optimal relationship. But what next is said in our requirement, you will probably find it helpful to graph the relationship. So since it has been said to create a relationship between EPS and debt ratio, it's better just to write down these ratios. So there are two ratios which are asked to create, debt ratio and earning per share, and this is your EPS. The values which are given, though they are present over here, but somewhere we need to calculate them. So it's better to write it as it is. So debt ratio is starting with 0, then we have 20, 40, 60, 80. Beside this, we do have our earning per share, and this is starting from 2.3, 3, 3.5, 3.95, 3.8. So these are earning per share. Ratios are present in front of you. And from here we will create a graph. Okay, so to create this graph, we will be having our axes ready for this. There are two axes, x-axis and y-axis. Debt ratio can be placed on x-axis and earning per share can be placed on y-axis. So here we will create our axis first. We need y-axis. For that, a vertical line would be created on left side. Beside this, we need a horizontal line as well for x-axis. Okay, now you can see that two lines have been created. Over here on y-axis, you are placing, since we do have two things, we will put earning per share over here, and on x-axis we can put debt ratio. One more thing, it should be equal to each other, so let's put them in this way. And these ratios would need be, how many terms we need in debt ratio? 1, 2, 3, 4, 5. So actually 4 are enough. Alright, one more column is needed. Let's add it and make it like this. Okay, so this debt ratio is actually placed on x-axis. So now 0 would be put over here, and at this stage you will be putting your inputs. First was 0 and then you have 20, 40, 60 and 80. So in this way relationship has been created at one side where that ratio has been mentioned. Over here you need, least point is 2.3. Let me see again. Yes, 2.3, and maximum point is 3.95. So you can create it with, if you will take 0.5, it would be 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Okay, perhaps it would be enough. So 0.5 we are taking. Let's see if it would be enough. Then 1.5, 2, 2.5, then we have 3, 3.5, then we have 4. Okay, so maximum need has been fulfilled. Align them to the right side. So these are the points on y-axis presenting EPS. On x-axis we do have debt ratio, and now let's create our points, for which we need a small points which would be posted over here. Let's make it size appropriate for our points. So here we have our first point and we need to put it at 0, 2.3. Look, 0 debt ratio is here and 2.3 would be present just like over here, 2.3. Okay, this is our first point, and now we will see second point. 20 is your debt ratio and second point is 3. So exactly at this point we do have 3, and now we will see third point, 40 and 3.5. 40 is here and we need to put it at 3.5, which is present over here. And next point is at 60 debt ratio, which is over here, and we need to put it 3.95. 3.95 would be nearby for at this. And now final point is at 80 debt ratio we have 3.8 EPS. This is our 80 ratio, and 3.8 would be at here. Okay, we have got our points, and now we will be joining these points. These different points are present. For that we will use again some lines. Here we have our first line, and what you will do, you will make it to join our first line, and then we have another line, one second. Okay, so this line we will join from here to here. So next line again we will join from here to here. Next line is also needed to join, and that is from here to here. What does optimal means? It means maximum relationship which can be created, and we have found out it. You can see that at this level, this is your maximum or optimal point, where what we have, debt ratio is 60 and EPS is equal to 3.95. So in this way, with the help of graph, we have created the optimal position. Optimal position, maximum relationship which can be created is now discovered, and this is your optimal position, and we can change its color as well, just to make sure that this look different. Alright guys, we have got our optimal point. So A part has been solved with the help of graph. We have created, look, it was said to take help from graph, optimal debt ratio. So optimal debt ratio has been created. Now second is graph the relationship between coefficient of variation and debt ratio. Debt ratio has already been posted over here. We again need to put it on graph. Let's take some space over here. Debt ratio, and you need to calculate your CV. CV, coefficient of variation, would be calculated by dividing standard deviation by EPS. And as you know that EPS is also given in our question, earning per share, standard deviation is also given. So simply what you will do, this standard deviation would be divided with EPS, earning per share. So it's better to write it so that we can have complete solution. At this stage you will note it down how much standard deviation was. It was already mentioned. EPS we have written. Let's put it down over here. And standard deviation we need to write again. Over here you will write your standard deviation. Let's arrange it in a proper way. Standard deviation first is 1.15, and then you have 1.8, after which we have 2.8, then we have 3.95 and 5.53. Alright guys, we have our standard deviation, we have our EPS, and since we have said our CV or coefficient of variation would be calculated, this CV is actually, I do not satisfy when I write abbreviation. Coefficient of variation, it would be calculated by dividing standard deviation. Please note it down. SD is your standard deviation, though I was saying that satisfaction level is not up to optimal stage because SD has been written as standard deviation. Standard deviation has been written as SD, which is present over here, and you can see that it is standard deviation, and this is your earning per share, and that is said as EPS. To calculate your coefficient of variation, you need to divide this standard deviation coefficient. This is your standard deviation and it would be divided by your EPS. First standard deviation is 1.15 and it would be divided by 2.3. Then again standard deviation is 1.8. You need to divide it with EPS 3. Next standard deviation is 2.8. Divide it with EPS 3.5. Again standard deviation is 3.95. You need to divide it EPS 3.95. Then standard deviation 5.3, divide it with earning per share 3.8. So we have got our coefficient of variation EPS, and standard deviation is used to calculate your CV. Again you will be creating graph for it. First two columns are needed, and okay, we need this graph. Let's make axis first. We need y-axis and x-axis. Let's put x first, and now we are making vertical axis means y-axis. This is not needed to be merged. Let's make it simple. So as usual, we will be putting our debt ratio and coefficient of variation accordingly. Your debt ratio would be posted over x-axis as usual. Here you will write your debt ratio at x-axis. On y-axis, you can put your coefficient of variation. So coefficient of variation would be posted over here. Let's make it in a proper way. Okay, that ratio is from 0 to 80. This is not needed. So here you can write 20, 40, 60 and 80. First point would be 20, 40, 60, 80, maximum requirement fulfilled. And from here you need to put points from 0.5, 6, 8, 1 and 1.4. So minimum amount is 0.5, maximum 1.45. So you can use 0.2 can be used, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6. Okay, our requirement has been completed. Now we will be posting our points. Let's take this point over here to use in the similar way. We have first point is at 0 and 0.5. This is the stage where your debt ratio is 0 and you need to put it at 0.5, which would be in between 0.4 and 0.6. So we have got our first point where your debt ratio was 0 and your CV was 0.5. Now next point is debt ratio 20. Debt ratio 20 is here and your CV is 0.6. 20 and 0.6 is present over here. So we have got our second point. Now third point is 40 and 0.8. 40 is here, 0.8 is present at this level. So we have got our third point. And now fourth point is 60 and 1. 60 here debt ratio and 1 is present over here. Then we have next point at 80, 1.45. This is your 80 and 1.4. For that 1.4 is present over here and 1.45 would be little up, slightly up. So we have completed our graph. Now it's time to join these points. Okay, to join we need a simple line. Let's hire this line and we will use it over here. To join this first line we will match both levels. This is your first and second point would be joined like this. Next line, first point is here and second point here. Then we have our third point to be sorted out. So graph is little time taking but really interesting to to make it on Excel. When you are making it on copy, you will have to use several instruments separately, and we are using it through Excel. This point was near down. Okay guys, so graph is ready for us, and this is relationship between debt ratio and coefficient of variation that has been sorted out. So from here you can create a relationship between both. Since you have got a positive relationship, this graph is showing a positive trend, so you can say that there is direct relationship between debt ratio and CV, or coefficient of variation. Coefficient of variation, let's see the spelling of coefficient of variation. Coefficient. Co we are actually not coefficient of relation, coefficient of variation. So what you have learned from these graphs: first graph was made between debt ratio and earning EPS. Again, a positive relation. As debt ratio would be increased, your EPS would also be increased. And from first stage, we have learned optimal point, the point which is at its peak, where both ratios are at its maximum. You can see that debt ratio relationship with EPS was at this point 3.95 with its maximum. Though your debt ratio was increasing, but by increasing your debt ratio, your earning per share was dropped. So what lesson you have learned? Increasing debt is okay, with which your EPS can be increased. But if you will take your loan out of the limit, you can see that your debt ratio has been increased, but due to increase in debt, though you have received your amount, but your EPS has been dropped. So it is optimal point, maximum loan you can take, or maximum debt you can take, the ratio would be 80. So this was your first chart or first graph, and second graph was relationship between debt ratio and coefficient of variation. So you can see that it is continuously increasing. Debt ratio is increasing. Beside this, your coefficient of variation is also decreasing. Not a good thing. Variation means when you are dispersed. Deviation means you are dispersed from your center. So both elements are going out of the limit. Here, positive relationship is saying if you will increase your debt, your coefficient of variation, standard deviation, would also be disturbed positively. Means one, due to increase in debt ratio, coefficient of variation would also be increased. So this was your question number 13.21, and both requirements were related to graph. We have made first graph, and then we have created our second graph. In first graph, optimal ratio. In second graph, we have just seen relationship between debt ratio and coefficient of variation. So 13.21 has been completed. Solution is in front of you. I'm very sure there would not be any difficulty in understanding this, but even then you are very open to ask your queries, questions through messages, text, or you can directly meet. If you are feeling any difficulty for creation of your graph on your copies, I will surely be available to solve your queries instantly. 13.21 is ended, and we'll surely be meeting again for the solution of any other question. Up till then, please take care of yourself, and I'm requesting you to please pray for me as well, and a humble request to please draw these graph by yourself as well. So after this 13.21 solution, it's time to end our lecture. Thank you very much for your time. It's time to say goodbye. Allah Hafiz.